Hi students, in the previous video, we have completed the introduction about the rate analysis and what are the requirements for calculating the rate analysis and along with overhead cost and just brief introductions details about the rate analysis. We have finished that one. So let me go for one small example how to calculate the rate analysis. So about this work cement concrete and which is 1 is to 5 is to 10 be the mixed design in foundation with brick ballast of 40 gauge and sand. So in foundation they are using cement concrete with this mixed design, and here 1 stands for cement and 5 stands for fine aggregate and 10 stands for coarse aggregate. I think everyone know about this. Here 10 be the coarse aggregate. The coarse aggregate, here the size of the coarse aggregate we have to use for 40 brick ballast. So this is small example and which is in textbook I am explaining. Okay, so how to calculate the rate for this particular work I am going to explain here in detail. And the unit range of unit is 1 cubic meter, so that we have to calculate the what is the 1 cubic meter of work or 1 cubic meter of work for this particular work, what is the rate. Okay, so let me go for some given data. First of all we have to write the given data. Okay, here so 1 stands for cement and 5 stands for fine aggregate and 10 stands for coarse aggregate. So for example, if this is the cement particles and this is coarse aggregates and this is fine aggregates. Okay, let me go for the some filling properties. So these are the coarse aggregates, some angular shapes. So in this coarse aggregate there is some gaps are there. Okay, so in this particular gaps fine aggregate is going to be filled. Okay, and okay, fine aggregate is going to be filled in this particular range. And next one, again fine aggregate is having some voids. In this fine aggregate voids cement is going to be filled. Okay, so this is called as filling property of the concrete. Okay, why I'm explaining this means so in the coming problem it will it will useful mainly, so that mainly cement we can use as a binding property and fine aggregate we can use as a filling property and coarse aggregate we can use as a strength. Okay, so I think everyone know about these clear properties about all the materials. Cement we can use as a binding nature. Cement is having a binding nature and fine aggregate is having a some filling nature and coarse aggregate having a strength property. Okay, okay. So before going to start this problem, so here the unit is 1 cubic meter we have to calculate. First of all, I'm taking take unit I am taking 10 cubic meter. It means I am calculating 10 cubic meter of work rate and it converts into the 1 cubic meter. This is my concept. So I am taking 10 cubic meter or I am calculating the rate as 10 cubic meter and finally I am converting into the 10 cubic meter. This is the procedure. Okay. And next one, For example, this is the 10 cubic meter work. So here in the previous case, I have explained the filling property. So I'm taking cement, fine aggregate, coarse aggregate. So when I'm going to mixing these three materials, so this is the 10 cubic meter concept. When uh, when cement going to be add, fine aggregate going to be add, coarse aggregate is going to be add, this 10, I mean after mixing this quantity, it becomes to this much, and this is also 10 cubic meter, but this is also 10 cubic meter. It means same materials we are using, okay, but when it comes to mixing nature, almost that volume is going to be reduced into in this part. For dry volume mixing, so you just remember this point, very important. Dry volume mixing in cement concrete, it should be, have to consider 50 to 60% be the dry mix volume. For example, additionally we have to take, it means additionally 10, we are considering 10 cubic meter, so that you have to consider extra 50 to 60% of this 10 cubic meter. You have to take the volume. Why? Because due to this filling nature. So again I'm repeating. So this is the coarse aggregates, and this coarse aggregate, there is some voids. In these voids, fine aggregate is going to be filled. Again fine aggregate is having some voids. In this fine aggregate, cement is going to be filled. Even though cement is having some voids, in that cement water is going to be filled. So due to this 10 cubic meter will reduce it to the some particular term, so that when it is going to be apply for the work, item of work, so that much of volume is not happened, so that we have to consider extra volume 50 to 60% volume is required. So for 10, we are taking here 10 cubic meter of the work assuming, so that extra we have to take 50 to 60%. So let it be the dry volume we have to calculate clearly. Okay, either it may be your choice, 50 to 60%, either 51 you can take, 52 you can take, 53, 54 up to the 60 you can choice, it's your choice. So that I am calculating dry volume, I am calculating the dry volume is equals to, unit be the 10 cubic meter plus 54 I am taking, that means 54% I am taking extra volume by 100, 54% be the 100 I am converting into, for which I am taking 10 cubic for 10 cubic meter. So it should be equals to the 15.4 cubic meter. It will be equals to the 15.4 cubic meter. We have to calculate the 15.4 cubic meter rate. But this 15.4 cubic meter, it equals to the 10 cubic meter. You should not worry about that. But for filling nature, we are adding 50 to 60%. You just keep it in mind. So, sir, for every work it will be changed means, yeah, it will change. So for cement concrete, it is a 50 to 60%. For brickwork, it will be 30 to 40% will be there. For plastering, 20 to 30% will be there. It will be depending upon the work. So finally, we have to calculate the rate for 15.4 cubic meter. And now you just will go to the one's question. And cement concrete, and the proportion is given as 1:5:10. Okay. Let me will go for the calculation. So already work is there. In the previous session, I explained the requirements. Clearly, I explained the requirements. First, work already defined. Materials also defined. What are the materials required for this? Along with these materials, we have to calculate the quantities. Now we'll go for the quantity calculations. This is very important parameter. Okay. First, cement. And the proportion I am writing 1:5:10. Am I right? Cement is equals to, cement is equals to, cement terms as 1 here, 1 divided by, and sum of this proportion. Okay, 1 plus 5 plus and 10. Okay, this is the proportion. For which quantity we are taking? 15.4 cubic meter. Am I right? So that into 15.4. Okay, so 1 be the cement property or cement proportion divided by the sum of all materials, that is mixed proportion materials, and product of the quantity, and it will be equals to the, I got cement quantity is 0.96 meter cubic. So here it is in cubic meter and the unit it will come only in cubic meter. So cement quantity in 15.4 and this value is equals to 0.96. So after this cement, and it is very easy to calculate fine aggregate and coarse aggregate. Why? Because product of 5 with 0.96 will get the fine aggregate and 10 with 0.96. So that fine aggregate is equals to 0.96 product of 5. Am I right? So 0.96 times of 5, it will be is equals to 4.8 meter cubic. And next one, coarse aggregate. Coarse aggregate, right, when here clearly defined 40 mm brick ballast. 40 mm brick ballast. Instead of coarse aggregate, you can write as 40 mm brick ballast. Why? Because in the question clearly they given brick ballast of 40 mm gauge. So that I am writing same thing here also. So that is 0.96 times of 10. So no, sorry. Yeah, 0.96 times of 10 and it will be equals to the 9.6 cubic meter. So when you summing up of 0.96 plus 4.86 8 plus 9.6, it around equals to the, you will get 15 point cubic meter, and this is the quantity distribution for the this particular work of cement concrete. Okay, so how we are calculating? Cement is equals to, cement big terms as a 1 divided by sum of these three proportion and product with the 15.4 cubic meter. I think you may clearly about how this 15.4 cubic meter getting. So and finally cement quantity it will equals to the 0.96 and finally fine aggregate is 4.8 and coarse aggregate is 9.6 cubic meter. Okay, and these are the calculation. Now in the market there is no cubic meter cost for cement. I think everyone heard about cement will available in 50 kg bag. 50 kg bags only cement cost is available, but fine aggregate coarse aggregate is quantity almost equals to the let it be in cubic meters only, but cement it will only in appear kgs or 50 kg packet. Let me, for 0.96 cubic meter how much kgs of cement is possible? Sir, what is mean by cubic meter? Cubic meter always you are saying, for example, this is this is 1 meter height and this is 1 meter width and this is 1 meter width in this direction. In the three direction, if you take the cement or if you add the cement in this particular volume, how much it will come, how many kgs are required to fill this 1 meter depth and 1 meter width and 1 meter length, how much kgs of cement is required. This is the cubic meter calculation as per the standard. I am saying clearly. So 1 cubic meter is equals to 1440 kgs of cement is required, and this is very important for the competitive exam bit. Okay, how many kgs for 1 cubic meter of cement? So it will be equals to the 1440 kgs. And for my case, here my case, what is this? 0.96 be the cubic meter. For 1 cubic meter it is 1440. And what about the 0.96? What about 0.96? When you cross multiplication, you can get this around, for my side it is some case. Let me will go over again, it will convert into the bags first. So one bag is equals to 50 kgs. Am I right? One bag is equals to 50 kgs. How many bags for 1440 kgs or otherwise 1 cubic meter? So I clearly explain is equals to simply 1440 divided by 50. Approximately it will be equals to the 29 bags. 29 bags. Okay, so for 1 cubic meter of cement is equals to 29 bags of cement will come. And next one, for 0.96 cubic meter, how many bags will come? So when you cross multiply, so clearly I am writing 1 cubic meter is equals to 29 bags of cement. For 0.96 cubic meter, it will be is equals to approximately 28 bags will come. Approximately 28 bags will come. So finally I have cleared about the quantities. So for 1 cubic meter it is 29 bags. I think clearly, I mean, about this calculations. So for 1 cubic meter it is a 1440 kgs of cement is required as per standard. And this one also very important for the competitive examination. When it comes to the bags, one bag is equals to how many kgs? 50 kgs. So when it this cubic meter will converts into the bags, 1440 divided by 50, you will get 29 bags. 1 cubic meter, how many bags of cement required? 29 bags. And for me 0.96 per cubic meter, it will be equals to the 29 bags. So that in the rate analysis, quantity of the bags will converts into the 29 bags, and fine aggregate is 4.8 and coarse aggregate is 9.6. Now we'll go for the main table. Okay, so and this is item number and this is item number, and next one particular of item, particular of item, and the next one is quantity or numbers, and the next one is very important case, rate, and the next one is cost. And this is the table for calculating the rates. Okay, now first one, first I am going to calculate the material cost. Okay, so what are the materials? One is cement, and the second one is sand, and the third one is 40 mm brick ballast. Okay, and what is the quantity of the cement? We already convert into the that is 0.96 cubic meter. This already convert into the bags. How many bags? 28 bags. Okay, and what is the sand quantity here? We already calculated in the top, that is 4.8 cubic meter, and the brick ballast 40 mm brick ballast is as coarse aggregate, and this one is 9.6 cubic meter. And very important parameter is here, rate. And rate, how we'll get this rate? Here I'm taking, it is not an approximate, I'm taking as textbook rates. And the textbook, which textbook I'm following is here, so Datta, B and Datta. So in this textbook, what are the rates available? I'm taking same the rates, but in the present market area it is not work out. Okay, it is not a similar thing for every year this schedule rates is going to be changed. Every year this SSR, standard schedule rate, is going to be published, so you have to consider the same rate. Okay, so approximately I'm taking in the what are the textbook rates I'm taking, okay, in B and Datta. Not only in BN Datta, Chakraborty, one of the textbook is there. In the textbook also rates are available. Same rates I am taking here. So cement rate are clearly mentioned. One bag cost is 330 rupees per bag. This is very important, you have to mention here. 330 rupees per bag. Okay. And the sand is 1500 rupees per cubic meter. And last one is for brick ballast. It is coarse aggregate. So this is 1000 rupees per cubic meter. You have to mention this one as clearly. If you miss this one, I think you will be confused. Okay. So these rates are not final rates. So I have taken from the textbook of BN Datta. Okay. So you can take present SSR also, it is very good. But I am taking from the textbook as BN Datta, and one more textbook is Chakraborty. You can follow these two textbooks for estimation costing value subject. Okay. So finally, when it comes to the rate calculation, right? Okay. So for one bag is 330 rupees, and for 28 bags, when you product 330 into 28, it will be equals to the 9240 rupees. And the next one for sand, 1500 into 4.8 cubic meter, it will be is equals to 7200 rupees. And the next one, 40 brick ballast, it will be is equals to 9600 rupees. This is the cost of material. So in the requirements we already finished. One is uh, work already defined. For foundation work, cement concrete we are using. For cement concrete, second step is the materials and quantity we already finished. These are the materials. One is cement, sand and 40 and these are the quantities, and this is the rate, and this is the cost. Okay, what about the next one? Labors. For constructing this foundation, labors must and should be required. Okay, and I'm going to summing this case here, how much will come. Sorry. Okay, and this value is equals to 26040.00 26,040 rupees. And the next one I'm going to calculate the labors. Okay, labors. So how many, I mean, different types of labors are available, I already explained the previous video. First one, head machine. And the second one, and it is a head machine, along with this machine is there. And third one is mazdoors, we can call it as beldar. And the fourth one is women are or boy are men or women coolie, boy or women coolie. And the last one, fifth one is bisti, he is a water person, you can call it as water boy. So along with say already defined lump sum is there, that is we can call it as the sunrise, you can say it as sunrise. Now we'll go for the quantities. Head machines, I already defined the previous video. Head machines is only half numbers, I mean half day is enough. Why? Because head machine is having not only this site, he is having 2 to 3 sites he is monitoring, so that half day his presence is enough. So that's why he kept a machines. So machines will be 2 to 4 numbers. So I am taking 2 numbers for this completion of work. And mazdoor, I clearly explained 10 to 12 numbers. So mazdoor requirement is more because foundation work I am taking 12 numbers. This is completely approximation. For completion of this, these are the labors required. And the next one, men or women coolie, 15 to 20 numbers is required. I am taking 18 numbers. And you can take approximately, this is not a standard If I take 17 also, no problem. Why? Because this completely rate analysis is approximation. For completion of this, how many is required? I have given standard parameters 10 to 12, 15 to 20, one or two numbers, half or one number. Your choice, you can take. I am taking water boy is having four numbers. And sunrise I'll take later. This is lump sum money. It is not any standard. I already explained what is this lump sum money. For laborers, you want some tea, biscuits, or whatever it may be. It's required. Am I right? It's a major requirement in the site. Along with different items will be there. Not only tea, chai. Okay, and we'll go for the rate here. Head machine. So this rate is as per textbook. I'm saying 425 rupees per day. This is very important, per day or per one number. You can take as per one number, not an issue. Why we'll go for the confusion? Okay, so per one number. Okay, per one number, head machine rate is per one number, and the machine rate is 400 rupees. Okay, and Mazdur rate is 250 rupees. No one will come for this rate today. Minimum 1000 be the rate for the Mashun or Mazdur, whatever it may be. But these are all textbook standards I am taking. When it comes to this SSR, it's clearly mentioned. And boy or woman coolie, it is 230 rupees. And Bisti also 230 rupees. Now we can go for lump sum. Your choice. More than 100 rupees you can take. I am taking 150 rupees. I am taking 150 rupees. Okay, and what about the next step? So this is the material or labor, and this is the quantity, and this is the rate, and this is the cost. We have to go for the cost. Okay, and this is the cost. How to get the cost? Product of this we can get the cost. So 212.50 and 400 into 8, 800 rupees, and this is 3000 rupees. And next one for boy or woman coolie, it is 4140 rupees, and this is 920 rupees when you product this. And finally this is 150. And finally I got for labor charges are 9222.50, that is 9000 rupees, 9222 rupees for labors. Okay, for material it is 26,040 rupees, for labor it is 9,222.50. Now we'll go for the final calculation, and finally, so that total labor and material cost, is equals to how much it is, around 335,262 rupees 50 pies. This is the total labor and material cost. Now very important factor here it will come. Now water is going to be very important in the coming days, so we have to pay, and we have to take, I mean, after paying only we'll get the water, am I right? So that we have to take extra charges for the water also. Add 1.5% of water charges. This is very important nowadays. In the 10 years back we are taking only 1%. Now it will be increased to the 1.5% of this 35,000. So around when 35,262.50 into 1.5%, it will comes around 528.9 rupees. 528.9 rupees. I am taking as 529 rupees. Okay, it's enough. Now I am taking materials, labors, and water charges. Who is going to be construct? Labors who are going to construct. But for monitoring all these labors, one person is required. That is contractor. So for contractor also having some property, he need some property profit. So that for contractor profit, It is a standard 10 to 12%. Contractor profit we have to consider as 10 to 12 for every work. Every quantity of work we have to take contractor profit. I am taking here 10% contractor profit. So 10 by 100 into 35,262.50. So it will come, I think everyone know, 3526.25. Now final workout. So final cost of, so cost of the cement concrete in foundation. Cost of cement concrete in foundation is equals to 35,000, that is labor and material cost 262.5 plus 529 to 529 rupees, that is water charges, and 3,526.25 rupees. And when you summing all these three parameters, it will come 39,317.75 rupees. This is the cost of cement concrete in foundation. So this work we calculated in quantity as 10 cubic meter. Have you remember in the starting? We calculated this work, entire work in 10 cubic meter. But in our problem, they given this work is 10 cubic meter cost. This is 10 meter cubic cost. But unit in the given question is 1 cubic meter I need. So for 10 cubic meter it is 39,317 rupees, but 1 cubic meter you just cross multiplication, you will get 3,931 rupees 0.77 rupees. So that for constructing cement concrete in foundation for 1 cubic meter rate is 3,931 rupees. So this is the calculation of rate analysis in cement concrete. So I'll go for just a brief. So first of all, we have to calculate the quantities, material quantities. So this is the filling property. So in the coarse aggregate voids, fine aggregate is going to be filled. In fine aggregate voids, cement is going to be filled. In cement voids, water is going to be filled. So this is 10 cubic meter of work. But when it is going to be mixing, it will reduce it to this much. So that we have to take extra 50 to 60%. Okay, we have to take extra volume 50 to 60%. Why? Because the volume is going to be reduced. So that's why I'm taking extra 50 to 60%. And unit you have to take, I mean, for you have to consider 10 cubic meter of work. So my work is 10 cubic meter. So finally we are calculating for 1 cubic meter only, but in the starting I'm assuming 10 cubic meter of work. So that calculation I have clearly explained, 50 to 60%. This is not standard. 54 I am taking. Why I am taking 54? It's I am taking approximately. In between you can take 50 to 60%. So that 15.4 cubic meter of work is there. For 15.4 cubic meter I have calculated the quantities. So cement, you just calculate the cement, and the remainings are very easy. So cement stands for 1 divided by sum of 3 mixed proportions, cement, fine and coarse, and product with the quantity, and cement will be equals to the 0.96 cubic meter, and fine aggregate when you product with the 5 you can get this, and when you product with the 10, 9.6 it will come. And when you, and main important is in the market, cement bag is in kgs, so that's why I have converted into bags. 1 cubic meter is equals to 1440 kgs of cement required, and one bag it will be is equals to 50 kgs, and I have converted 1 cubic meter, how many bags will come means 29 bags. Okay, and approximately it will be is equals to 28 bags for my quantity. Based upon that, this is the tabular column, item number, particular of item, quantity, rate and cost. And the rate, how I taken rate means here from textbook I am taking B.N. Datta textbook. Directly I am taking these rates, but every year rates are available in the standard schedule rates. It will be revised, and also it will be published every year. So finally material cost this much, and labor cost this much, and finally we have to add the 1.5% of water charges, and we have to add the contractor profit for every work. This is very important, 10 to 12%. In some textbooks it be given as 12%, but I am considering 10% for easy calculation only. And this is the format, or this is the calculation of rate analysis for particular work. So in the next video we'll go for the how to calculate the cement or RCC work in beams and RCC work in columns. Okay, so thank you so much.